Namaskar. One more case in regression or linear regression, classical approach, and this time we are going to study the effect of change of scale on the coefficients of regression or rather calculation of coefficients of regression. Find out the two lines of regression for the following set of two variables, and there are two variables x and y. X, the values of x are in hundreds because common element or rather common factor is 100, not the 1000. And in case of y, all the figures or numbers or values are with one decimal place. Let us calculate first of all mean. If we can take assumed means equivalent to actual mean, that will be very nice. In case of sigma x bar is 22,600 divided by 10, because the summation is 22,600 and n is 10. So x bar comes to 2,260. See, all the values are in hundreds, but the mean is in tens. So it is not advisable to take the assumed mean exactly equal to the actual mean. So we have to take any value in hundreds, that is advisable. So in case, and one more thing, since the common factor is 100, it is advisable to divide all these values by 100 so that the minimum possible values of x will be available. Now there will be nothing like x, but we are going to create a new variable u by subtracting a value in hundreds. That is called assumed mean. What should be assumed mean? It is my suggestion to take assumed mean always less than the actual mean, so that there will be positive total of the new variable, and since it will be positive, the possibility of error because of the negative sign will be minimum. This is my suggestion. There is no such rule. You can take assumed mean greater than actual mean also, but my suggestion is to take assumed mean always less than actual mean. What should be the ideal assumed mean in this case? In this case, the ideal assumed mean is 2200 because it is less than actual mean as well as it is in hundreds. So we are going to take 2200. And now the deviations will be in hundreds, so we can easily divide it by 100. Now this is called change of origin. There is no problem with change of origin in case of calculation of coefficient of regression. But this is change of scale, division or multiplication. And the coefficient of regression is not independent of change of scale. So at the time of calculation, we have to give the reverse effect of this 100 in the formula or steps of calculation. Now what will be the reverse? The denominator or numerator, where there is u, we will have to multiply it with by 100, because here we have divided by 100. So as a reverse effect, we have to multiply the coefficient by 100, where the summations of u or u square are used. Now in case of y, the mean is 20 by 10, 2 or 2.0. So it is 2.0 with one decimal place. So in this case, it is advisable to take the actual mean itself as the assumed mean. So the new variable v will take the place of y, and that will be y minus 2 or 2.0. Now all the values are with one decimal place. So I advise to divide all the values by 0.1. If one decimal place is there, divide it by 0.1. If two decimal places are there, divide them by 0.01. There must be two decimal places here also. If these are with three decimal places, then divide them by 0.001. If these are with four decimal places, then divide them by 0.0001. So the place of 1 is dependent on the number of decimal places in the original values. Since there are only one decimal place, 1 is as the first decimal place. If there are two, 1 will be at number 2, 3, 4 and so on. Here also all the summations of v in the formula should be multiplied by 0.1, because here we have divide all the values by 0.1, that is change of scale, and we have to give the reverse effect. Now u will be 2800 minus 2200, that is positive 600 divided by 106. 2000 minus 2200 minus 200 divided by 100 is minus 2. 2100 minus 2200 minus 100 divided by 100 is minus 1. 2200 minus 2200 0. 2300 minus 2200, that is 100 divided by 100, positive 1. 2500 minus 2200 is positive 300 divided by 100, it is positive 3. 2400 minus 2200, positive 200 divided by 100 is positive 2. 2300 minus 2200, result is 1 exactly. 1900 minus 2200 minus or negative 300 divided by 100, negative 3. 2100 minus 2200 minus 100 divided by 100, minus 1. Summation of positive numbers is 6 plus 1, 7 plus 3, 10 plus 2, 12 plus 1, 13, positive 13. Negative is 2 plus 1, 3, plus 3, 6 plus 1, minus 7. So summation is 6. Now the question is this summation correct or not? Let us check. Actual mean minus assumed mean, and actual mean minus assumed mean. Okay, actual mean is 2260, assumed mean is 2200. So summation comes to and divide it by n. So it is 60 by 10, 6. So the total is correct. This is just a checkpoint. You cannot find it in any reference book. This is my own way. This is my own suggestion. Let us find out V. 2.8 minus 2 divided by 0.1 is positive 8. 1.8 minus 2 negative 0.2 divided by 0.1 negative 2. It is something like 18 minus 20. Similarly, here also 0, 4, 0, minus 2, minus 3 and minus 2. Positive total is 8 plus 4, 12. Okay, it is 12. Positive total. Negative total is 4 plus 1, 5. 5 plus 2, 7 plus 3, 10. Okay, minus 12. It is 0, sigma V. Now, summation of deviations taken from actual mean is always 0. See, we have taken the assumed mean exactly equal to the actual mean. So, summation must be 0, and it is. That means this column is correct. This column is also correct. So, now the possibility of error in the all remaining columns are minimum. UV. 6 into 8, 48, minus 2 into minus 2, 4, minus 1 into minus 2, 2, 0 into minus 1, 0, 1 into 0, 0, 3 into 4, 12, 2 into 0, 0, 1 into minus 2, minus 2, 3, minus 3 into minus 3, 9, minus 1 into minus 2, 2. See, this is a risk point. Only one value is negative. There are chances of forgetting the negative sign. Please be careful. 48 plus 4, 52 plus 2, 54 plus 12, 66 plus 9, 70, 5 plus 2, 77, minus 2, it is 75, sigma UV. Now U square. U square, square of all U values. 6 square 36, 2 square 4, 1 square 1, 0, 1, 9, 4, 1, 9 and 1. 40, 41, 42, 51, 55, 56, 57 and 9, 66, sigma U square, 66, and the last is V square. 64, 8 square, 2 square 4, 2 square 4, 1 square 1, 0, 16, 0, 4, 9 and 4. 64 plus 9, 73 plus 16, 89 plus 4, 93 plus 9, 102 plus 4, 106. sigma v square 106. Okay. Now the coefficients of regression, first of all, let us take byx n sigma uv minus sigma u into sigma v upon, since x is independent variable and u represents x, so n sigma u square minus sigma u the whole square. Now reverse effect of this change of scale. We had divided all values of x by 100, so we have to multiply them by 100 in this case, and the other will be numerator. We have to write both of these. It is something like Cx will be denominator, so Cy will be numerator. Let's substitute. N is 10, sigma uv is 75, minus sigma u is 6 and sigma v is 0. Upon n is 10, sigma u square 66 minus sigma u the whole square into Cy is 0.1 upon Cx is 100. Please don't forget this step. Where there is change of scale, we have to give the reverse effect. And that's why I always advise to use the change of scale by division only, so that the reverse effect by multiplication in the formula will be very easy. See, u represents x and the factor of change of scale in case of x is to be multiplied in the denominator. If you multiply for the purpose of change of scale, this will be reversed. And that is troublesome, that creates the possibility of errors. All these are suggestions. You can take them as rules in your personal cases, but I talk all these as suggestions because there should not be any rigidity. Many argue that, sir, in the era of calculators and computers, why should we go for all these change of scale and change of origin, blah blah blah. But at the time of study, we should not think like that, just learn. It will be 750 minus 6 into 0, 0 upon 660 minus 36 into 0.1 upon 100. So ultimately it is 750 upon 624 into 0.1 upon 100. I am not going to simplify this. Now use calculator. So ultimately byx will be, I have already used the calculator, it comes to 0.0012. This value can be so small and exactly reverse. Bxy will be n sigma uv minus sigma u into sigma v upon, y is independent variable in this case and v represents y, so n sigma v square minus sigma v the whole square into, now we have arrived at v by dividing all y values by 0.1, so now as a reverse effect we have to multiply it by Cy. So Cx will be numerator. Let us substitute the values 10 into 75 minus 6 into 0 upon 10 into sigma v square is 106 minus 0 square into Cx is 100, Cy is 0.1. So it is 750 minus 0 upon 1060 minus 0 into 100 upon 0.1. So it is 750 upon 1060 into 100 upon 0.1. Now use the calculator and the answer is 707.55. So Bxy is 707.55. Now this is turn of lines of regression. First line of regression of y on x. And the standard form is y cap equals to a plus bx, where b stands for byx A we have to find out, and the formula of A is y bar minus byx into x bar. Y bar is 2 minus byx is positive 0.0012. X bar is 2260. Here also be alert. Substitute arithmetic mean, not the assumed mean. Many students make mistake at this stage of substituting assumed mean instead of actual mean. Please be careful. So ultimately it is 2 minus, I have already calculated it, 2.712. So A comes to minus 0.712. Y cap is A, that is minus 0.712, plus B for byx 0.0012x, or in positive order it is 0.0012x minus 0.712. Now it is turn of line of regression of x on y. The standard form is x cap equals to c plus by, b stands for bxy. The formula of calculating c is x bar minus bxy into y bar. X bar is 2260 minus bxy is 707.55 into y bar is 2. So it is 2260 minus 1415.1. So C comes to 844.9. X cap equals to C plus by. Therefore, x cap equals to 844.9 plus 707.55 x. This is the line of regression of x on y. So this was the case where we used change of origin as well as change of scale. Be careful, study carefully this case and try to understand the reverse effect of effects and reverse effect of the change of scale. That's it. Thank you very much.